when you classify your polynomials, we do it by the degree. So if we have a degree of 0, that's called a constant. Okay, and an example would be x to the 0 equals 1, or y equals 1. A polynomial with a degree of 1 is linear, and an example would be y equals x, or y equals x plus 2. A degree of 2 would be quadratic, y equals x squared, or y equals x squared plus x plus 1. As long as your highest degree is a 2, it's a quadratic. To the third degree is a cubic, y equals x cubed, or y equals x cubed plus x squared plus x plus 1, or any combination of those, as long as your highest degree is x to the third. And the polynomial with a degree of 4 is called quartic, y equals x to the fourth, and it could look anything like this. Okay, for the next section, we are going to find the leading coefficient, degree, and constant term, but the first thing we should do is put it in standard form. That means our degrees are in descending order, which in this case is 4, 3, 2. So this is actually in standard form. The leading coefficient is the number in front of the term with the highest degree, which in this case is the x to the fourth term. So the leading coefficient would be a -1. The degree, of course, would be 4, and the constant term here is 9. It is the term without any variable attached to it. In the next problem, if we look at this, our equation is not written in standard form, so we need to rewrite it. F of x equals -2x cubed minus 3x squared minus 9. So the leading coefficient would be right here in front of the highest degree, -2. Our degree is 3, and the constant term is -9. For number 3, we're just going to rewrite the equation in standard form. So f of x equals, my highest degree is 4. Make sure you carry the negative sign with the x. So x to the fourth plus x cubed is my next one. I'm going to cross them out because it'll be easier for me. Minus 2x squared plus 3x. There's no constant term, so we can just leave it as that. Number 4, f of x equals, my highest degree right here is this negative x to the fifth. So I'm going to rewrite that, -x to the fifth. My next highest degree is positive 2x to the fourth. There is no x to the third term, but here's an x squared, and it's positive x squared. And x term is plus 10x, and again, there's no constant term. For number 5, we're going to use direct substitution, which means for every x, we're going to plug in a 2. So f of 2 equals -2 times 2 to the third minus 2 times 2 squared plus 4 times 2 plus 10. Remember now, in the order of operations, we always square or raise the term to the exponent first before we turn back and now multiply it by that number. So if we were to carry through here, we'll have 2 to the third, which is 8, minus 2 times 2 to the fourth, which is 4. We can multiply that out, plus 8, plus 10. Now if we simplify this, we have -16 minus 8 plus 8 plus 10. So these will cancel, and we'll get -16 plus 10, or -6. In the next one, we're going to plug in -1 for all our x's. So f of -1 equals 2 times -1 to the fifth plus 3 times -1 to the third minus a -1. Be careful, make sure you use parentheses. So we will raise our numbers to the powers first. So we will have 2 -1 to the fifth power will leave us -1, plus 3 times -1 to the third power is -1, minus a negative will give us +1. So if we simplify, we have -2 minus 3 plus 1, and that will give us -4. Okay, for number 7, we're going to solve the equation. Now remember, before we solve, we need to factor. So we ask ourselves, is it written in standard form, which in this case it is. So the next thing we'll ask ourselves is is there a greatest common factor? And in this case, there is no greatest common factor. Since there are 4 terms, we're going to group. We're going to factor by grouping. So in this first pair, we can factor out an x squared to get x plus 1. And in the second pair, we're going to factor out a negative 9, and we will also end up with x plus 1 inside our parentheses. Our x plus 1s become our first factor, and our other factor is x squared minus 9 equals 0. Remember to check if you have an x squared in your binomial here, make sure it's not difference of 2 squares. In this case, it is. So this is difference of 2 squares, which means this breaks up into x plus 3, x minus 3, and make sure we carry down the original x plus 1. Now we have it fully factored, but the question is asking us to solve it. So we need to set each one of these binomials equal to 0, which means x equals negative 1 is our first solution, x equals negative 3 is our second solution, and x equals 3 is our third solution. Okay, for number 8, we're checking to see if it's in standard form, which it is. Next thing we want to do is, can we factor out a greatest common factor, which we can. Actually, 3 will go into both of these terms, and so will x squared. So we'll have 3x squared on the outside. We'll have just x squared left over, minus 16. 3 goes into 48 16 times. Now, once we look at this binomial with the square in it, we realize that it's difference of 2 squares, and we'll break it up into 2 factors, x plus 4, x minus 4, and make sure we continue carrying down the 3x squared. Okay, now that we have our factors, we're going to solve and set each one equal to 0. So for 3x squared, we'll treat this the same way as any old algebra problem. We get x squared equals 0, and then we take the square root of both sides. So x equals 0, x equals negative 4, and x equals 4. Okay, for number 9, we check to see if it's in standard form, which it is. And we notice that there's 3 terms, so we can just factor this the way we were factoring quadratics with our a, c, and b. So ac is 1 times 6, or 6. So what multiplies to 6 and adds to negative 5? This one's a little tricky. It would be the negative 3 and negative 2. So since there's no number in front of the x squared, our 2 factors would just be x minus 3, x minus 2. Set it equal to 0, because remember we're solving. So x minus 3 equals 0, x minus 2 equals 0. So x equals 3, and x equals 2. For number 10, we look at it first. Is it in standard form? Yes, it is. Second thing we want to know, can I factor out a greatest common factor? In this case, I can factor 2 out of everything. So I will have x cubed plus 2x squared minus x minus 2 equals 0. Since there are 4 terms, we're going to group. So we'll group the first 2 and the last 2. So we can factor an x squared out of this one. We'll have x plus 2. A minus 1 out of this one, x plus 2 equals 0. So x plus 2 is our first factor, and x squared minus 1 is our other factor, equals 0. Now look, we have an x squared. Let's make sure and see if it's different to 2 squares, which it is. So that factors further into x plus 1, x minus 1. And we have to carry down our original x plus 2 factor. So x plus 2 equals 0, x plus 1 equals 0, and x minus 1 equals 0. So we have x equals negative 2, x equals negative 1, and x equals 1. Last one is an extra credit problem. I'm going to check the standard form, yes. I'm going to factor out a greatest common factor. I'll end up with x to the 4th plus 8x equals 0.